called special cases. They're going to be binomials, so they're only going to be 2 terms. Okay, so you're not going to be looking at 3 terms or 4 terms, it's just 2 terms. Okay, so anytime you see 2 terms, the first thing you need to do is check for greatest common factor. The next thing you need to do is check to see if it's one of these 2 special cases. Okay, the first special case is the difference of 2 squares. That means, difference means what? Subtraction. So it has to be, if it's a binomial, it has to be subtraction. These are your requirements for it to meet the qualifications for the difference of 2 squares. It has to be subtraction. That's the word difference. It has to be a binomial. Doesn't work if it's not. All coefficients and constants must be perfect squares. We talked about perfect squares before. 4 is a perfect square because 2 times 2 is 4. 16 is a perfect square because 4 times 4 is 16. A perfect square means you can take the square root of it and it's even. It's a whole number, okay? And so all coefficients and constants must be perfect squares. Now, coefficients are the numbers in front of your variable. Okay, that has to be a perfect square. So it has to be 4, 16, 25, 36, 49, okay, and so on. It has to be a perfect square. But your variable also has to be a perfect square. And we know that it's a perfect square if its exponent is even. If its exponent is even, for example, x to the 6th is a perfect square because x to the 3rd times x to the 3rd is x to the 6th. Okay? X to the 10th is a perfect square because its square root is x to the 5th. So all you have to do is take that exponent and divide it by 2, and that tells you what the square root of it is. Okay? And so that's why we say all exponents must be even. Okay? Okay, factoring the difference of 2 squares is very simple. Once you recognize that it is the difference of 2 perfect squares, okay, it's going to be equal to a plus b times a minus b. Meaning it's the square root of your first term plus the square root of your last term, and then the square root of your first term minus the square root of your last term. Okay, we know we always factor these. They end up usually being a binomial times a binomial, and that's what it'll be. One will be plus, one will be minus. Yes. Okay. And so this says we always check for our greatest common factor first. Always, always, always. Because the difference of 2 squares can be hidden. Okay? It may not look like the difference of 2 squares at first, but if it has a greatest common factor, that you take that out first, what's left might be the difference of 2 squares. Okay? And so remember we said it must be subtraction, because difference means subtraction. This does not work. If it's the sum of 2 perfect squares, this will not work. You take the square root of each term. One factor is addition, the other is subtraction. It is actually very simple. The hardest thing is recognizing that it's the difference of 2 squares. Yes?
So, that's also the subtraction. I think one of the terms in the equation is subtraction and log plus minus. Like at the last bullet point, you see how it says
yes.
x squared?
Yeah. One's always going to be plus, one's always going to be minus. But this has to be a minus right here for you to be able to do this. It has to be the difference of 2 perfect squares for you to be able to jump straight to that step. Okay? The AC method actually still works for this. What are we missing in here? We're missing that middle variable, right? If we put a placeholder, say we put 0x, and then, let me do this over here. You don't have to write this down, but let me do this over here. So let's say we have x squared, and we add a placeholder, plus 0x minus 25. And then let's do the AC method with it. So I have to figure out the factors of negative 25 that multiply to equal that, but combine to equal 0. It's 5 and 5, and one of them has to be negative, right? Okay? So my 2 factors are x plus 5 and x minus 5. So you can continue to do the AC method with these, but if you recognize that this is a perfect square and that's a perfect square, because what's the square root of x squared?
5.
X squared.
Oh.
X. And what's the square root of 25? 5. So you can, that is the difference of two perfect squares. So we can automatically write, one's going to be plus, one's going to be minus. The square root of x squared is x, so it's going to be x times x. The square root of 25 is 5, so it's going to be 5 times 5. Because what happens when you go to check it? Your middle term disappears, right? Yes?
How do you know one's going to be plus and one's going to be minus?
Because that's the pattern. That's the pattern that you follow. It's always one's going to be plus, one's going to be minus. That's going to work out every time because look at what happens. Let's check. X times x, that equals x squared. That's our first term, right? Positive 5 times negative 5 is negative 25. That works, right?
What if it was a positive?
Then you can't do it. It won't work. It has to be negative because look at what happens. When I go to check my middle term, I'll do it this way. We have positive 5x and negative 5x. That, when I combine those, that equals 0, right? That means I don't have a middle term. That can't happen if this was plus 25 because you couldn't find two factors that multiply to equal positive 25 but combine to equal 0. You understand? One has to be positive and one has to be negative for there to be no middle term. Does that make sense? Okay, so that's why it's the difference of two squares. The sum of two squares won't work because if you say x squared plus 25 and you factor that and you want to say, oh, that's x plus 5 and x minus 5. When you check that, your middle term is 0, but when you multiply positive 5 times negative 5, you get negative 25. Okay? It's not possible to make that happen like that. So if you have x squared plus 25, it can't be factored. X squared plus 25 can't be factored. Okay? But you still can solve. If you wanted to find what x was equal to, x squared plus 25 equals 0. Okay? But let's not forget, our whole purpose in this is we're going to be solving these equations. You have to factor to solve. Just because it can't be factored doesn't mean you can't solve. You don't need to write this down, but if we had x squared plus 25 equals 0, how would I solve that? I bring the 25 over there, right? So x squared equals negative 25. Square root both sides. So x would be plus or minus 5i. Okay, so it still can be solved. Okay, and likewise, x squared minus 25 equals 0 can be solved the same way. If we move 25 over, we get x squared equals positive 25. Then we take the square root of both sides. We have x equals plus or minus 5, which is what we're doing here. If you set each one of these factors equal to 0, x would be equal to positive 5 and x would be equal to negative 5. Okay? So I don't want y'all to forget the big picture. Okay? Factoring leads us to solving these equations. Okay? And in chapter 9, we're going to start simplifying rational expressions, which means they're like fractions, but you have variables in the top and variables in the bottom. And you have to factor so you can cancel things out. Okay? So that's also where we're leading and why we're doing this. Okay? So let's look at this one. X squared minus 49y squared. No, there's no equal sign. There's nothing to move over. We're just factor. Okay. Is it the difference? Yes. Is it two perfect squares? Okay, let me ask you this. What's the square root of x squared? What's the square root of 49y squared? 7y. Okay, great. So that means, so one's going to be plus, one's going to be minus, x and x, and then 7y and 7y. It is easy if you recognize that it's the difference of two squares. Okay? Okay, but they could have a problem disguised like this. 2x squared minus 98y squared. Is it the difference? Yes. Is that a perfect square? 2 is not a perfect square. 98 is not a perfect square. But do I have a greatest common factor here?
Yes.
I can divide them both by 2, right? So first I factor out my greatest common factor. So that's 2 times x squared minus 49 y squared. Now I have the difference of 2 squares. But remember, 2 is my first factor. You can't lose that. Okay? So now this will factor to 1 plus, 1 minus, x plus 7y, x minus 7y. So there are 3 factors of this. The first one is 2, the next one is x plus 7y, and the next one is x minus 7y. Okay? Any questions? Yes.
If you tried to check that, we just factor the deduction.
If I wanted to check it, we have 3 things to multiply together. So you multiply the first 2. So that's 2x plus 14y. I factored out the 2, so now I'm going to redistribute it if I want to check. And so that's times x minus 7y. Okay? Now, I redistribute this. First, I distribute the 2x. Okay? 2x times x is 2x squared. 2x times negative 7y is negative 14xy. Right? Now we distribute the 14y. 14y times x is positive 14xy. Do you see what's going to happen? My middle terms are going to cancel. Yeah, right. 14 times negative 7 is going to be negative 98y squared. So my middle terms will cancel, just leaving me with 2x squared minus 98y squared, which is what we started with. Okay? So to check it, you just redistribute it. Factoring and distributing are opposites of each other. One undoes the other one. Okay? Any other questions so far? Okay, so y'all try that one. Okay, we know that this is a perfect square and this is a perfect square, right? And it's the difference. So if we know that, you go here. One's going to be plus, one's going to be minus. What times what? What's the square root of 9? 3. What's the square root of 64? 8. What's the square root of x to the 6? X to the 3rd. What's the square root of y to the 12th? Okay, so ask yourself this. Okay, I need to fill in. This times this has to equal this. So 3 and 3, and it's going to be y to the what?
No, x.
X to the 3rd and x to the 3rd. Now when I multiply those, I get that.
So it's 8 to
8 and 8. Yes, y to the 6 and y to the 6.
Okay, I get it. I'm trying to scroll.
I'm going to rewrite these. That looks nice.
So it's
There was a question. Does it matter if I put minus first and then plus? No. Why doesn't it matter? Because we're multiplying, so you can reverse them and it's still the same answer. Okay? Okay, so for this one, it's 2 perfect squares. Okay, so we know one's going to be plus, one's going to be minus, or reverse. Okay? What times what's 100? What times what is s to the 8th? S to the 4th times s to the 4th. Okay? Now, if I were to begin to FOIL this, I would do 10s to the 4th times 10s to the 4th is 100s to the 8th. Okay? Now, and what times what is x squared? We know this. X times x. Okay? So if I were to FOIL this, I check my last terms. X times x is negative x squared. Good. If you check your middle terms, they would cancel because there is no middle term. Okay? Any questions? Okay, so that's the first special case, the difference of two perfect squares. The next one is the sum or the difference of two perfect cubes. Okay, now, this is going to be just a pattern that you're going to have to memorize. Okay, I don't have any special neat way to show you that you could do AC method or anything like that with it, because you can't. Okay, these are cubes, they're different. So the sum or the difference, now this one could be plus or it could be minus of two perfect cubes. You have to know what a perfect cube is. A perfect cube means if you take the cube root, it will be a whole number. Okay, into the calculator, you go math, it's in the math menu, and go down to number 4. Okay, the cube root, let's say the cube root of 8 is 2, because, yes, because 2 to the third power equals 8. So perfect cubes are not as easy to spot. And some of these problems, they'll give you big numbers. So you don't know right offhand. Like I know right offhand that 8 is a perfect cube. I know that 64 is a perfect cube because 4 times 4 times 4 equals 64. I know 27 is a perfect cube because 3 times 3 times 3 is 27. But after that, I don't really have the rest of them memorized. Okay? And so, is 1 a perfect cube? Yeah. 1 times 1 times 1 is 1. Okay, the cube root of 1 is 1. 1 is perfect everything. It's a perfect square, it's a perfect cube. Okay. And so you need to get familiar with that cube root button in your calculator. Okay, so again, it's a special binomial. All right? It could be addition or subtraction. And they both have to be perfect cubes. Which means, when you look at the exponents, we're not checking to see if they're divisible by 2, we're checking to see if they can be divided by 3. If x to the 9th is a perfect cube, because I can take 9 and divide it by 3 evenly, okay? But x to the 16th is not a perfect cube. I can't take 16 and divide it by 3 evenly. X to the 16th is a perfect square, because 16 is divisible by 2. So again, you need to keep exponents and whole numbers separated in your mind, okay? So when you're checking to see if an exponent is a perfect cube, as long as it's divisible by 3, it is. As long as the exponent is a multiple of 3, then it is a perfect cube. So, to factor with cubes, okay, and remember it could be addition or subtraction. There's 2 different patterns you're going to have to fill in. But once you know these patterns, it's simple to fill it in, okay? But you're going to have to memorize it. Put them on note cards, check yourself, test yourself. That's the only way you can memorize it, but you have to memorize it. I'm not going to give it to you. So, check for greatest common factor first. Because remember, just like I showed you with the difference of 2 squares, sum or difference of 2 cubes can be hidden. It might not be recognizable at first. If you've got a greatest common factor, take it out. Okay? Okay, now, once we put the pattern, the first thing you're going to do, it's a binomial times a trinomial. And I'm going to show you when I move down, okay? But it's always going to be a binomial times a trinomial. Your answer is going to be a binomial, 2 terms, times a trinomial, 3 terms, okay? Just like when we did difference of 2 squares, we put 1 plus, 1 minus, right? We know what the signs are. The pattern for the signs, there's an acronym called SOAP. Same, opposite, always, positive. That stands for SOAP. Same, opposite, always, positive, okay? And I'll show you what that means in a minute. So you put your signs first in your answer. After you do that, you take the cube root of each term and match the sign. So these are the things you need to remember. So, same, opposite, always, positive. And then when you fill in the actual terms, it's square multiplied square. Okay? So, and this just simply takes practice. So here are the 2 patterns. This is the difference, and this is the sum. Okay? So, if this is a minus, you do it one way, and if that's a plus, you do it another way. Now, it's the same square multiply square for both of them. The only thing that's different are the signs. Okay? So, like I said, you always put a binomial times a trinomial. So you'll do this. Binomial times a trinomial. Okay? And let me get this up so everybody can see. Okay, so you'll do binomial times a trinomial. Okay? Then you put your signs. So, same, opposite, always positive. So, if it's the difference of two perfect cubes, this is going to be the same, which is going to be a minus. This is going to be the opposite of that. And the last one's always positive. So if it's the sum of two perfect cubes, your signs are the same. The next one is going to be the opposite, so it's going to be a minus. And the last one is always positive. Same, opposite, always positive. No. No, because this is the same as this. Same. This one's going to be the opposite of that.
Oh, not the opposite of...
No, the opposite of the first one. The opposite of the first one. Or the opposite of the original. Okay? Same, opposite, always positive. The first one will be the same as the original. The second one will be the opposite of the original. And the last one will be always positive. Okay. Did that make it more clear?
Wouldn't that negative be the same, the first one's same?
This one's the same. This one's negative. So this one has to be negative.
Yeah.
This is a negative. This one's opposite.
Oh, to that one, I thought.
Yeah.
And then the last one's all.
And the last one's always positive. In both cases, it's always same, opposite, same as the original, opposite the original, and always positive. Okay. Good. So, your pattern, binomial times trinomial. Same, opposite, always positive. Put your signs. Then square, multiply, square. Okay. In your binomial, it's just like the difference of squares. You're going to put square root, or cube root and cube root. Okay? Cube root and cube root goes in your binomial. That square, multiply, square is how you fill in the trinomial. Okay? So, x to the third, the cube root of it is just x. Right? Because x times x times x is x to the third. So that goes here. So that's the cube root. So that will just be x. The cube root of your second term is just y. Okay? So in the binomial, it's cube root and cube root. Okay? In the trinomial, it's square multiply square. Which means we're not looking at this anymore. We're just looking at this.
And you take the
Square the first term. We're not taking the square root, you square it. So that's x squared. Then you multiply the two together. So that's x times y. And then you square the last term. So that's y squared. So it's the same thing. So cube root, cube root. So cube root of x to the third is x. Cube root of y to the third is y. Then you look at this. You square it, you multiply, and then you square it. So x squared is x squared. Multiplying, that's x times y. Y squared is y squared.
So the first term and the last.
So you could write like this, maybe. So it's the cube root, cube root, cube root, plus, let me write it bigger. Cube root plus or minus cube root, depending on what your sign pattern is, right? That's your binomial. Then you have your trinomial. The last one's always positive, but could be plus or minus, depending on what your pattern is. And then it's the square, so it's the first term squared. Then multiply the two together. Then square the last term. Square the first, multiply them, and then square the last. I don't know if maybe that helps. Okay? And once you do this a few times, it gets easy. But you just have to learn this pattern first. So when we're looking at a binomial, if you have to factor a binomial, the only options you have are greatest common factor or special cases. That's it. Or greatest common factor and one of the special cases. Okay? You're not looking at quadratic formula, there's no middle term. You're not looking at the AC method, there's no middle term. So it's just special cases and greatest common factor, that's it. If you're looking at a trinomial, it's greatest common factor, AC method. And if you're looking at 4 terms, greatest common factor, grouping. Okay? So you have to learn to, first of all, when you look at these problems, when they're all mixed up and all the methods are all put together, the first thing you should do is count how many terms it is, because that narrows your options. Okay? So let's look at this one. 8x to the third power plus 1. It's a binomial. I don't have a greatest common factor, so I'm going to check to see if it's one of my special cases. Are they perfect squares? No. 1 is a perfect square, but this is not. 8 is not a perfect square. Are they perfect cubes? Yes. I can take the cube root of 8. It is 2. And x times x times x is x to the third. Okay? So to figure out the cube root of your variable, just take your exponent and divide it by 3. So we know that it meets the specifications. So this is going to equal binomial times a trinomial. Okay, wait. Let's put so first, put your parentheses. Binomial times a trinomial. Then our signs. Same, opposite, always positive. So it's going to be the same as the original. It's going to be the opposite of the original. And the last one is always positive. Okay? In the binomial, cube root and cube root. 2x and 1.
Oh, because 1 doesn't have a cube root.
Well, it does. Cube root of 1 is 1, because 1 times 1 times 1 is 1.
Oh.
1 to the third power is 1. Okay? Now, I'm done with this, right? So now we're going to do square multiply square. Square the first term. 4x squared. Wait. Everybody see where we got 4x squared? Because if you take 2x, and square it, you have to square each one individually. 2 squared is 4, and that's x squared. Okay. Then you multiply the 2 together. So when I multiply 2x times 1, what do I get? 2x. And square the last term. 1 squared is 1. And that's it.
That's it.
It's easy if you remember the pattern. Okay? Doesn't matter. If it's big numbers, your calculator can take the cube root of a big number. And you can divide any exponent by 3. Okay? If you have to square an exponent, you just double it for the exponent. Okay. So try this one. Let's check everybody. So it's the sum of 2 perfect squares. So we go to our pattern. Binomial times trinomial. The same is plus. The opposite is minus. Always positive. Okay? Cube root and cube root. 3x and 4y. Alright? Square multiply square. Square the first term. 9x squared. Multiply the 2 together. 12xy. Square the last term. 16y squared. Good job, guys. Any questions? Try that one. It's two perfect cubes, so we know it's going to be binomial times trinomial. Same, opposite, always positive. Same as the original, opposite the original, always positive. Okay? Cube root, cube root. This is where you may make a careless mistake. Calculator can tell us the cube root of 64 is 4. But the cube root of x to the 6, all you do is take that 6 and divide it by 3. That's x squared. Because x squared times x squared times x squared is x to the 6. Or you can think about x squared to the third power is x to the 6. Okay? Or you could think about the cube root of x to the 6. Okay? Do y'all remember if you have a radical and we want to write this as a fractional exponent? Do y'all remember how to do that? This is x to the 6 divided by 3. You take this exponent and divide it by that. Okay? So that's x squared. I mean, some people might connect better with this. If I need to take the cube root of x to the 18, no, not 18. Yes, 18. That's x to the 18 divided by 3, which is x to the 6. Some people might find it easier to do it that way. Okay? All right. So, the cube root of y to the 9th is y to the 3rd. All you do is take an exponent divided by 3. You're getting the square root divided by 2. Cube root divided by 3. So y to the 3rd. Okay? Now, square multiply square. When we square the first term, 4 squared is 16. X squared squared, that's x squared squared is x to the 4th. Okay? So we squared the first term. Now we have to multiply the two together. That's 4x squared y to the 3rd. You're multiplying the two together. That's 4 times 1. And then just x squared times y to the 3rd. Okay? Okay, now we square the last term. So that's y to the 3rd squared, which is y to the 6th.
This is grown man work.
Grown man work. Okay. We good? Y'all need one more to try? One more. Might as well, right? Make sure you got it down pat. Was everybody finished with the other one? Okay, try this. Let's see. All right. So it's going to be binomial times trinomial. Same, opposite, always positive. Cube root of 125x to the 3rd is 5x. The cube root of 8y to the 12th is 2y. 12 divided by 4 is, 12 divided by 3 is 4. So it's 2y to the 4th. Cube root, you just take that exponent divided by 3. Okay, now square the first term. 25x squared. Nope, 5. Gotta square 5 also. Multiply them together. 5 times 2 is 10. X, y to the 4th. Okay, now square the last term. 2 squared is 4. Y to the 4th squared is y to the 8. Any questions? Yeah. Right. Okay. Yeah, so be careful. Okay, now, you don't need to write this. Now, solve equations. We have to set it equal to 0, factor it, And then once you factor it, you set each factor equal to 0. Okay? And so in this example, we have to first, before you begin, it has to be set equal to 0 to begin with. So that's 6y squared minus 48y equals 0. Now, if it has an equal sign in it, it wants you to solve it. If it doesn't have an equal sign in it, don't add one. Don't make one up. Okay? If it doesn't have an equal sign in it, you're just factoring it. But if it has an equal sign in it, you're solving. Okay? And so, when I look at this, it's a binomial. Do I have a greatest common factor?
Yeah.
What is it?
6y.
So we have 6y. And what's left? Y minus 8. That's factored, right? Can it be factored any further? No. What's left in parentheses is factored as far as I can get it. Now, so in a sense, we have 6y is one factor. Actually, 6 is one factor, times y is another factor, times y minus 8 is the third factor. Okay? You set each factor equal to 0 and solve. Now, the exponent tells you how many answers you'll end up getting, your highest exponent. So I know for this problem, I should have 2 answers. There will be 2 places that this problem crosses the the x-axis. Okay? And so, we take 6y, set it equal to 0. 6y equals 0. And then y minus 8 equals 0. So you set each factor equal to 0 and solve. So when we take, so it's like 2 separate problems. So we divide both sides by 6. So in this one, y equals 0. The first solution is 0. So in my solution set, 0 is my first answer. In this one, we move 8 to the other side, so y equals 8. So my second answer is 8. So those are the roots. Those are the solutions. Those are the zeros. Those are the x-intercepts. They just happen to use y as a variable in here instead of x. Okay, that's the whole reason why we're factoring, so that we can figure out those solutions. Okay? So let's look at this one. See an equal sign? We have to find the answer to this. Okay? So, how many terms do I have?
4.
So what method of factoring am I going to use? Grouping. Grouping. So we're going to use grouping. Because if I couldn't factor this, there's no way I could figure out what x was equal. Well, there is, but we're going to learn that in a minute. Okay. Right now, we're going to try to factor it, because once it's factored, we can take each one of those factors, set it equal to 0, and solve. How many answers should I end up getting? 3. There are 3 solutions. My highest exponent is 3.
Oh,
There may not be 3 real solutions, but there's going to be 3 solutions. Some of them may be imaginary, I don't know. Okay, so we're going to group. So I'm going to group my first 2, then my second 2, and it's each step equals 0. Each step equals 0. Sometimes, most of the time, these problems are not already set up equal to 0. You have to move things over and make it equal 0. Okay? And so, my greatest common factor in my first group is x squared, right? So then that's x plus 1. In my next group is negative 4. X plus 1 equals 0. So my 2 factors are x squared minus 4 times x plus 1 equals 0. Every step you need to write equals 0. If you don't, you're going to forget that you're solving. Once it's factored, oh, wait a minute. Is it finished being factored? No. What can still be factored? X squared minus 4, what is that? The difference of 2 squares. That's the difference of 2 perfect squares. Well, you could right now set them each equal to 0 and solve. But it will be the same thing. You'll get the same answer. Yes. Okay, I'll do it both ways. All right. So let's factor this. This is the difference of two perfect squares. So that's x plus 2 and x minus 2. Right? And then I still have x plus 1 equals 0. And you set each factor equal to 0. So x plus 2 equals 0. So this first solution is x equals negative 2. X minus 2 equals 0. So this first solution is x equals positive 2. And x plus 1 equals 0. So this solution is x equals negative 1. That is all three solutions. So negative 2, 2, and negative 1.
So when you do that, you do the x squared minus 4 and say equal to 0, you got answer for the plus or minus?
Yes, so we'll do that next. Okay? If you don't factor it, if you don't factor this further, and you just set x squared minus 4 equal to 0, that's perfectly legal. Okay? Then you take the square root of both sides, but don't forget the plus or minus, because you won't see both solutions. Okay? Okay, so now I will do it the other way, as if, let's say we set these factors equal to 0 right here. X squared minus 4 equals 0. So we move the 4 to the other side, so x squared equals 4. Then we take the square root, so x equals plus or minus 2. That's two answers. X equals positive 2 and x equals negative 2. See, if you don't factor it further, a lot of times people will forget.
Move the negative 4 open before you would have square rooted it, or that, like you would put x.
You did this? You can't do that. Okay, so this one's already factored for you, right? So all we do is set each factor equal to 0. So x minus, it is easy. X minus 2 equals 0 and x plus 3 equals 0. Okay? And so x equals positive 2 and x equals negative 3. Okay? Now, this one, how many terms are in the second one?
2.
3. And it's number 2 in the second one. There's 1, 2, 3 terms.
Oh. I thought we were
1, 2, 3. Okay. We're on number. Oh, you thought I said how many solutions?
Yeah.
Yes, we're going to get 2 answers for this one. Okay? We better get 2 answers. If you didn't get 2 answers, maybe you forgot a plus or minus or something along the way. Okay, so first thing I need to always check to see if there's a what? Greatest common factor. Is there? Yes, I can divide everything by 2. So that's 2 times. Okay, so that's 3x squared minus 13x minus 10, right? Now, for this trinomial, you have 2 options to factor it. You have 2 options to find the solution. You can either use quadratic formula, or you can use the AC method. Okay? So you can use either method, whatever you're most comfortable with. I'm going to use the AC method. Okay? Because quadratic formula, I tend to make careless mistakes when I use that often. Okay, so A times C is what? Good. A times C is negative 30. So my factors that multiply to equal negative 30 but add to equal negative 13 are 10 and 3. Well, let's see, 10 and 3. One of them has to be negative, right? Well, when you add that, what do you get?
You get negative.
Negative 7. That's not right.
So you got
So it's not 10 and 3, because it doesn't matter which one I make negative, I'm not going to get negative 13. So it's not 10 and 3. What else could it be? 15 and 2. 15 and 2. Which one has to be negative? The 15. Because the larger one has to be negative to equal negative 13. Okay? So 15 and 2. So, I still have my 2 here. So I'm going to split my middle term up into these two. So I have 3x squared minus 15x plus 2x minus 10. Okay? And if you want on your paper, you could take this off to the side and do the AC method. And then once you get your final factors, put them back right here. Okay? That's up to you, however you want to organize it. And so now we're going to group. So we're going to group these two and these two. But don't forget, you still have this 2 on the outside. It's the first factor. You can't lose it just yet. Okay? So when I take my greatest common factor out of my first group, that's what?
3x.
3x. Leaving me with x minus 5, right? And my greatest common factor in my second group is 2, leaving me with x minus 5. And all that's equal to 0. Yes?
So, question. When you have, like, any number doesn't keep, but it has like a high exponent, that is 2x.
You're talking about when it's the difference of 2 cubes?
Yeah, like that, it's like 2x to 7 minus 32. Like one of them can add.
I would, if they can't both be done, then you can't do it. Okay, let me finish this problem and then I'll be happy to come with that. Okay, so now this is 2 times 3x plus 2 times x minus 5 equals 0. Right? Y'all with me? Now, what do I do next? Set each factor equal to 0. We factored it, now we need to solve. Factor and solve, factor and solve, factor and solve. So, we have 2 equals 0. That's my first factor, right? 2 is my first factor. 3x plus 2 equals 0, and x minus 5 equals 0. Now, can 2 equal 0? No, that's trash. At this stage, I could have divided both sides by 2 and gotten rid of the 2 that way also. Okay? Now, I move this positive 2 over and it becomes 3x equals negative 2. Divide both sides by 3. X equals negative 2 thirds. That's my first root. Move the 5 over, x equals positive 5. That's my second root. So my solution set is negative 2 thirds and 5. Because my highest exponent is 2. That means I'm going to have 2 solutions. They may not always be real solutions, but there are going to be 2 of them. Okay. Now, any questions? Okay. This is your homework. However, I adjusted 33 through 40. Instead of doing all of them, you just have to do these odd numbers. And I expect you to check your answers in the back of the book to make sure you did those correctly. Any odd numbered problems, I expect you to check and make sure you're doing them right. And this is not even, it's every other even. Okay? It's page 348. Yes, because we spent a lot of time on section 6.4.